Welcome back, everyone. Today, we're taking a highly structured, super deep dive into the world of securing cutting-edge AI. I mean, as artificial intelligence literally transforms entire industries overnight, the frameworks we use to govern and audit this tech, well, they have to evolve just as fast. So in this explainer, we're going to break down exactly how you apply the rigorous standards of ISO/IC 42001-2023 to the absolute bleeding-edge frontier of emerging AI. But before we get into the nitty-gritty, I want you to consider this really profound challenge. How do you audit a machine whose decisions you can't even understand? It's a fascinating question, right? When we apply ISO/IEC 42001 to modern, totally opaque AI systems, we aren't just looking at static lines of code anymore. No, we're dealing with systems that learn, adapt, and sometimes make choices that, honestly, even their creators struggle to fully explain. This means we need a massive shift in perspective. Think about a traditional IT audit. It involves clear rules and static code. You test the inputs, you check the outputs, and boom, you can trace exactly what happened in the middle. But an AI system audit, that is a completely different beast. Now we're dealing with dynamic learning and black box opacity. Because AI learns and adapts continuously, auditing it requires an entirely new, specialized approach just to ensure the system remains secure, reliable, and compliant way after it's been deployed. Okay, let's dive into this. First up, we'll explore the AI compliance frontier. Then, we'll tackle machine learning opacity. Third, we'll navigate NLP algorithmic bias. Fourth, we'll take a rapid-fire tour through autonomy, blockchain, and quantum computing. And finally, we'll wrap up with something incredibly practical, the auditor's toolkit. So we're going from a visionary tech tour straight into highly actionable strategies. All right, Section 1. The AI compliance frontier. Let's set the stage for the ultimate safeguard in AI innovation. To audit the future, we need a brilliant anchor, and that anchor is ISO/IEC 42001-2023. This is the new global standard specifically designed to guide organizations on AI risk management throughout the entire lifecycle of an AI system. We're talking from design right through to deployment and continuous monitoring. Basically, this standard is fundamentally built to keep our AI systems secure, reliable, and fundamentally fair by demanding strict transparency, robust risk management, and crystal clear accountability. It's the definitive framework that proves an organization is balancing AI innovation with intense responsibility. Moving on to Section 2, Machine Learning and Opacity. We're transitioning into a world where algorithms can get, well, a little too mysterious for traditional compliance. Look, machine learning is arguably the most prominent technology in AI today, but it brings a massive compliance challenge to the table. We call it the black box problem. This happens when a model's internal decision-making process is completely hidden from its users, and like I mentioned earlier, sometimes even its creators. This opacity directly challenges the core transparency requirements of ISO 42001. Imagine a machine learning model predicting patient outcomes in a hospital, or deciding your credit score, and you literally can't explain how it reached that conclusion. That is a severe compliance failure right there. So what's the fix? The fantastic solution to this opacity challenge is explainable AI, or XAI. This is exactly what auditors look for to bridge that transparency gap. XAI uses specific models and techniques, things like shop values, for example, that make the reasoning behind AI decisions clear and actually understandable to human operators. For an auditor, verifying the use of XAI means verifying that decisions, especially those high-stakes ones like healthcare predictions, can actually be justified and trusted. Transparency isn't just some buzzword here. It is a documented, absolutely crucial technical requirement. Section 3, Navigating NLP Algorithmic Bias. Let's move to natural language processing and see how this builds into the complex ethical challenge of human language. Natural language processing, or NLP, is the tech behind the chatbots, voice assistants, and resume screeners we use every day. But it is deeply susceptible to amplifying human biases that are baked into its training data. Let me give you a scenario. What if an AI recruitment tool exhibits gender bias? Imagine an NLP system screening resumes that systematically downgrades female candidates simply because it was trained on historically biased hiring data. This is not just an abstract concept. It is a real-world, high-stakes nightmare that completely violates the fairness principles of ISO 42001. And it's exactly what lead auditors must hunt down and prevent. So, the crucial point is that auditors have to actively look for specific, documented safeguards to mitigate these NLP risks. A company can't just promise their AI is fair, they literally have to prove it.
As an auditor, you're checking. Do they actively diversify their training data? You're looking for deployed content moderation filters to stop offensive outputs. And since NLP often processes highly sensitive human conversations, you must ensure strict GDPR privacy alignment. We're talking encrypted personal data and logged user consent. Plus, you want to see proof of continuous model audits to catch any performance degradation or new bias creeping in over time.
All right, Section 4, Autonomy, Blockchain, and Quantum. Let's shift gears into a rapid-fire tour of the absolute bleeding edge of tech. These technologies are moving so incredibly fast. First up, autonomous systems. Think self-driving cars or delivery drones. The standard demands rigorous testing and validation here to ensure physical safety, reliability, and totally clear accountability if something goes wrong. Then we have blockchain. This is a super cool game changer for auditors because integrating blockchain with AI creates a perfect, immutable audit trail. It lets us permanently trace and verify AI decision-making. No way around it. Finally, quantum computing. It promises exponential computational power for AI, but man, it introduces massive security risks. Auditors have to evaluate if organizations are anticipating how quantum power will actually impact their current encryption and performance baselines. Which brings us to Section 5, the Auditor's Technical Toolkit. How do we actually secure these futuristic tech trends today? We do it by slowing down and grounding ourselves in foundational controls. And this brilliantly illustrates how we do it. Lead auditors and compliance officers need a highly actionable cheat sheet, mapping emerging AI risks to specific technological controls and tying them directly to ISO 42001 goals. Want to protect against data breaches in AI? You deploy AES 256 encryption to maintain confidentiality. Need to prevent unauthorized model manipulation? You use detailed access matrices to enforce integrity. And to catch real-time adversarial attacks, we utilize intrusion detection systems to ensure availability. But listen, just having the tech isn't enough. The documentation has to be absolutely flawless. Stringent documentation must prove to an auditor that the CIA triad, confidentiality, integrity, and availability, is fiercely protected. For example, if you say you use AES 256 encryption, your documentation has to detail exactly how the encryption keys are managed. Are you utilizing a hardware security module, or HSM, for secure key storage? For access control, auditors want to see detailed role-based access control matrices that prove you are enforcing the principle of least privilege. You have to document exactly who has access to the AI models and that sensitive training data. That exact same rigor applies to monitoring. When you're evaluating an intrusion detection system, or IDS, auditors look for a very exact sequential procedure in your documentation. Step 1, clearly defined configuration rules governing inbound and outbound traffic. Step 2, exact anomaly thresholds, like what specific behavior actually triggers an alert. Step 3, established alert protocols dictating exactly who gets notified when a threshold is breached. And Step 4, maintained logging and response procedures detailing how the organization recovers from the incident. It's this level of detail that transforms theoretical AI security into proven, auditable compliance. Which leaves us with this final, provocative thought. As quantum computing and other emerging tech accelerate AI development at absolute breakneck speed, is your documentation ready to secure the future? By embracing the structured rigor of ISO/IEC 42001, you aren't just reacting to technology, you are proactively governing it. You have the tools, you have the framework, and now you know exactly what to look for. Thanks for joining me for this explainer, and I'll catch you in the next one.